the universe appears endless, powerful, and eternal. Galaxies stretch across unimaginable distances, stars continue to burn, and space itself keeps expanding. But what happens when the universe finally reaches its absolute limit? Not a temporary crisis or a local collapse, but the final boundary beyond which existence itself can no longer continue in the form we understand today. Every system in the universe depends on balance. Gravity holds galaxies together, electromagnetism binds atoms, and quantum forces control particles. These interactions create stability and allow structure to exist across every scale of reality. However, the universe is not static. From the moment of the Big Bang, it has been evolving continuously. Stars are born and die, galaxies move apart, and energy spreads through space over immense stretches of time. As the universe evolves, entropy increases. Entropy is the gradual movement toward disorder and equilibrium. Over time, usable energy becomes less available, reducing the ability of the universe to create structure and motion. If this process continues forever, the universe may eventually reach a state where no further change is possible. This is often described as the heat death of the universe, where everything settles into maximum entropy. In this distant future, stars will no longer exist. The materials needed to form new stars will be exhausted, and existing stars will have burned out long before the universe reaches its final state. Galaxies themselves will fade. Without active stars producing light, the universe becomes darker over unimaginable timescales, leaving only remnants drifting through expanding space. Black holes may dominate this era for a long time. Their immense gravity allows them to absorb remaining matter and energy, making them some of the last major structures left in existence. But even black holes are not eternal. Through Hawking radiation, they slowly lose mass over incredibly long periods of time until they eventually evaporate completely. After the final black holes disappear, the universe approaches near total emptiness. Only low-energy particles and faint radiation remain, spread across an ever-expanding void. At this point, interactions become almost impossible. The distances between particles grow so large that they may never encounter one another again, leaving the universe nearly motionless. Time continues to exist, but without events or interactions. It loses meaning. Nothing changes, nothing evolves, and nothing new can emerge from a frozen state of reality. Some theories suggest that even matter itself may not survive forever. Protons could eventually decay into simpler forms of energy over unimaginable timescales. If proton decay occurs, the universe loses even its most basic structures. Matter disappears entirely, leaving behind only extremely low-energy radiation and isolated particles. Quantum fluctuations might still appear briefly in empty space. Tiny particles could emerge from energy for short moments before disappearing again into the vacuum. However, these fluctuations would not restore the universe. They are temporary and unstable, unable to rebuild stars, galaxies, or complex structures in any lasting way. Some physicists believe these fluctuations could eventually trigger the birth of a completely new universe, beginning another cycle of cosmic evolution under different conditions. Others believe nothing follows. The universe may remain trapped forever in a state of silence, emptiness, and maximum entropy, without any possibility of renewal. The universe reaching its absolute limit is not an explosion or sudden collapse. It is the final exhaustion of all structure, energy, and interaction across reality itself. What happens when the universe reaches its absolute limit is the ultimate ending of cosmic evolution, a state where nothing changes, nothing grows, and nothing remains except endless stillness spread across infinite darkness forever.